Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
So today, I'm very excited about this episode and this opportunity to have you join us on the Grid Mod Pod. I think we could talk all day, which is becoming a saying that I say almost on every one of these. To our listeners, this is Ryan Quint. He is the founder and CEO of Elevate Energy Consulting. And I just want to throw it over to you, give you an opportunity to introduce yourself, Ryan.
Thank you, Liz. It's an honor to be here, and very excited to be on the podcast, and sort of reconnect with a longtime friend from many years ago. So it's great. My background, for those that don't know, I recently left NERC, the Electric Reliability Organization for North America, to start Elevate Energy Consulting. And in my past role at NERC was the Director of Engineering and Security Integration. So was intimately involved with all of the IBR and inverter-based resource, distributed energy resource work, particularly around industry stakeholder engagement, building up the IRPS and the SPIDER WG groups, which are the technical stakeholder groups under NERC. And so really working collaboratively with the team and working collaboratively with the industry. Before that was with the Dominion Virginia Power and Bonneville Power Administration, where I started my career. And just decided recently to try a new angle, still very much aligned with the vision of my past role of helping industry collaboratively, but as opposed to from the regulating perspective, I now am doing sort of consulting and jumped into the mud and rolling up my sleeves and helping industry much more intimately. So I'm very excited about that.
Yes, it's very exciting. And honestly, it's a need because I'll just say I just spent 2 days with multiple utilities where we were talking about all things battery energy storage systems. And within that conversation, it was all about inverter-based resources and the implications of them and how to integrate them into not only the transmission grid, but the distribution grid. And so having the next set of worker bees or the workforce to understand truly the technical needs is a viable skill set that we not only need to have, but then also trickle that down to all that are engaged. So I think you're doing an amazing thing. So, from your past role, let's just dive in. You were deeply involved in analyzing really large scale disturbances of these inverter-based resources. And so I like to educate a little bit on this podcast, but that really means any systems or devices that are connecting to the AC grid, but were created from a DC. So it's inverting the DC to the AC. So think solar, wind, and then even some battery energy storage events. What were you seeing from your experience, the themes, and really what kind of reportings and what is that in a nutshell for our listeners?
I think the theme.
We can always try it again because it takes, I think, the average human to retain information 7 times before they get it.
Yeah. Yes. Well, I'll try to define IBR 7 times in this discussion, hopefully.
There we go.
But I think the theme really is the rapid pace of change that the industry is undergoing today. And this concept that grid transformation is not coming, it's already here, and it's in many ways sort of behind us or affecting us now, right? So it's often implicit, but it's important to say it out loud because everything centers around that. I think, the resource mix is changing very, very fast. Look at the interconnection queues, look at Lawrence Berkeley's work. 95+% of the interconnection queue is entirely inverter-based, right? Batteries, wind, solar, and hybrid plants, which are combinations of both. Along with that, you have the fossil fuel-based resources, which are predominantly synchronous generators, are also rapidly retiring for economics, policies, what have you, right? So the combination of those two creates sufficient problems to keep us busy in perpetuity. And then you pile on data centers, AI load, crypto mining facilities, EV growth, and all that just says our load forecast is tremendously off and underestimated, which is in the wrong direction of an estimate, right? And so we're sort of stuck in the middle as the bulk power system. How do we make this whole thing work? So that to me are the impending problems, but underlying that is that fact of we're going to a almost purely power electronic based inverter based grid, right? So the technology is changing, not just these, we've got new variable resources, is that the grid of the future does not look like the grid of the past. And that's often taken for granted by people that maybe aren't experts or technical, ultra technical, right? So the concepts of stability and weak grids and all of these other things often get glossed over, particularly in policies, right? But they are the things that hold the system together.
Just to pull on the thread, stability, for the transmission grid, which is three-phase, stable, balanced system, or that is the optimal state. When you say stability, ultimately the grid is responding to 60 hertz frequency. So all of these massive machines are spinning, and the goal is to maintain stability. And so when we interject this enormous amount of IBR, that whole kind of foundational knowledge has to be looked at differently. I mean, just fundamentally.
Exactly.
So that word stable, I think we all take for granted, of how challenging it is to keep the grid of the past running, let alone transforming it to this new reality.
And that like technology advancement, right, is what we learned through all of these now infamous events, from starting all the way back from the Blue Cut fire in 2016 to the infamous Odessa events, which were like a very close near miss major event for us.
Do you want to tell us a little bit about both of those events?
Sure, yeah. So in 2016, we had an event in California where 1,200 megawatts of solar tripped off unexpectedly for a normally cleared fall, right? So the amount that should have been tripped off was zero, right? The amount that did trip off, 1,200 megawatts. That's a lot of power, right? The system's designed to withstand like 2,700 megawatts of resource loss. And beyond that, you're hitting the threshold of the system's not designed to handle that, right? So that 1,200 was scary. And then we started seeing that over and over, right? Over the course of a dozen events, we started continually seeing solar misbehaving or abnormally responding to these grid events and ultimately tripping or disconnecting or reducing power output. And then it just sort of seemed like, okay, this is a California problem, right? They've got an earlier fleet of solar inverters that were sort of pre some of the new requirements and the new understandings. And so you can kind of give them a out for that, right? This older technology, older vintage. And then ERCOT, the Texas interconnection, really like blew up with solar over the last handful of years. And then in the blink of an eye, they had an event in 2021, and then a recurring event almost caused by the almost identical cause of the event. And they saw a bit much bigger event, right? So those findings are critically important, that it's not just an older vintage problem. It's a systemic problem that we've got to get a handle on brand new facilities that came online like the month before the event happened, right? So when you really do like the root cause analysis, the most important thing we learned was what happens in real time is an artifact of how you planned and designed and engineered your system, right? And so were these issues studied during the planning process? No. Well, why weren't they studied? Well, because were your models accurate? No. Well, why weren't your models accurate? Do you have requirements that disallow bad models? No. Right? So you sort of have to ask, like, who's at fault here, right? Which side of the fence is really the one to blame? Regardless of, like, it's not a blame game, but regardless, we've all kind of collectively recognized, like, we need to really up our game or elevate our game, if you will, right? To kind of get better in all of these areas.
I guess I can't help but think of, where we first met was around the phenomenon of fault-induced delayed voltage recovery. That was something that was occurring and did occur in dairy farms, where you had, motor load that wasn't being represented, you could say, accurately in the models or the simulations that were running way before the solar and wind conundrum. And so, and what we were driving there in the conversation there is, are the system models that are being developed or being used? So really, why were they developed? So I love to think about like where we were, where we are, where we're headed, and where we ought to be. And that was a signaling to the industry. And I remember sitting in those forums and listening to us all developing a model that was more accurate to real-time events. we're still playing catch up. And now we're on to, even bigger, larger events. And so the cautionary tale is allowing the space to, I don't think you and I both know the answer, but we can at least help champion and give the food for thought of how to take these really large systems too big to fail and break them down and start gathering the correct data to rebuild the way we run our power flow solution models. And I think both of you and I had a colleague that was the man who put together the original solution package that was never designed and built to do what we're trying to do with the systems today. And what we're talking about is the power flow simulation software that's available to us. So all that to say is we haven't got ahead of it. If anything, we're kind of rapidly falling behind because we're not gathering, what would you say, right? Like what can maybe the work product and all of the standards and maybe the directives that are being given, help, or how does that guide or create, a pathway to get ahead of this?
Yeah, it's a challenge we know we face as an industry. We've always faced it. We face it within the utilities themselves. And I worked at two utilities. It's always a challenge, and then it challenge at the regulatory level as well. You don't want the regulations to sort of outpace or hinder or preclude innovation, but then also if they fall too far behind, they're sort of irrelevant, right? So there's always this balance of like, well, where are we in that spectrum? And that it goes back to that like rapid pace of change, just accelerated so fast. When you really look at it, it was almost a flat line in terms of technology innovation, load growth, resource mix setting, and then all of a sudden a hockey stick upwards, right? In terms of, wind was kind of a gradual growth. We've learned a lot about wind over 20 years, but then solar is just rapidly taking off, and batteries are just outpacing that even, right? So it's that just basic maturity model, right? Of like understanding the technology and then working back to the fundamentals, right? So there's been a lot of work that's gone into uncovering these things. That's what I was mostly involved in, is like,
Right.
let's figure out the root of all of this and try to share broadly with what needs to be done, right? Along with that has come, regulations at the FERC level, and then work plans at the NERC level on how they're going to make changes there. So, I guess if I jump into that piece, I think FERC Order 2023 was a big step in changing the landscape. That was around the interconnection queue reform, this backlog of interconnection queue. We sort of recognize we need to get renewables on the grid faster. We've got these multi-year interconnection processes that tend to be much longer than other parts of the world. And so how do we speed that up? Well, we go from a first ready or a first come first serve process to a first ready first serve cluster study process. So that's a large exercise in process reform, right? It's a process reform is what it is. Baked into that were some very technical sort of meaty requirements around having good data, providing the data, making sure it's kept up to date through the process, which is very much linked back to the type of discussion we're having here. And then following that was Order 901, which was the mandate to NERC to update the requirements, the NERC standards in many of these areas. And it was really a copy paste of the work that had been done at NERC for 10 years or so around, okay, we found all these things, we've learned all these things, now go codify that in standards. So, you kind of ask yourself, like, did it take 10 years? Like it took 10 years for us to have multiple near miss events, and now we're going to start the process of updating the requirements, right? So that's a challenge, right? And it's focused on.
So 10 years, but ultimately there is this change, right? That's coming.
It's coming, yeah, exactly.
Right. So, what are, and I think you spoke a little bit to them, but just to kind of be specific, what are the specific changes that, we will be seeing due to the 10 years of work? Now, granted, can the next version be quicker? We shall see. But
yeah, so the things that are coming down the pike are performance requirements on inverter-based resources, so ride through capability, speed of response, all these things, very technical, but that links back to how the resources are procured in the first place, going all the way back to the OEM, making sure that we're getting resources that are built robust enough to meet these grid requirements. Then there's performance validation, is what I call it, which is this concept that stems from protective relaying, right? When we have a fault on the grid, protective relay engineers jump right on it, they figure out what happened, and they go fix it. right? I had a misoperation, so I fixed my protective relay, right? And I'm sort of mandated to do that with an existing NERC standard, and then it's just best utility practice, right? So we
Right.
fix misoperations and things that go wrong on the transmission system. That concept hasn't historically really applied on the generation side, particularly on the IBR side. And a lot of times it's the unit will trip off, or a handful of turbines will trip off. They come back automatically in 5 minutes. The facility's unmanned, right? So it's just, I don't know, the resource comes back online. It's everything's fine. It was a hiccup, right? But when 20 plants all hiccup at exactly the same time caused by a grid problem, right? That's where a bad day gets created. So that's what this performance validation standard is requiring entities to be able to identify abnormal performance proactively and then try to address those. And that links back to, do I have the monitoring equipment to be able to do that? So that's another standard that's coming. And then did my model reflect this performance? And did I validate my model sufficiently? So that's an incoming requirement. Did I have an EMT model as well as a positive sequence model? So this whole concept of electromagnetic transient modeling is this whole new modeling challenge facing us, right? So it's just really
That's
revamping.
becoming a requirement.
On top of that is, I guess I'd throw out is this, the IBR registration, right? So this was all applicable to resources that were 75 MVA and above at 100 kV and above. And that sort of set a higher threshold. And those numbers were created when IBRs were still relatively small. You know, even wind was kind of small in terms of the level of penetration. And so NERC's bringing those numbers down from 75 at 100 to 20 at 60 kV. Right, so it's all of the sub-transmission and smaller transmission resources that are going to be going through. I had no requirements, essentially, no performance-based requirements imposed on me to potentially the whole suite of NERC standards, right? So they're going through a tremendous change here over the next 3 years. There's a 3-year staged work plan for that.
Yes, and I think just for our listeners, right, like everything you talked about really will impact every business unit within a utility. And I think a lot of those looking on the outside looking in do not understand the intricacies involved within an internal utility, just within the engineering department, let alone the operations, right? And then you think about the financial incentives and your compliance requirement officers and right, all of those that are bestowing that internally. And what you're saying is like these new standards, it has been shown that if we don't effectively gather the correct data from the moment of procuring or saying yes to the development of a specific project, it can cascade and bleed into all the way to real system operations. And so, what other way or what other device or what other system can be created in our human behavior that can remove all of the information and strictly share what is real and relevant? I mean, that's like a human behavior, human issue, global problem. We have so much information, it's hard to digest what's true and real. So in the end, there has to be a set of engineers and under those that can develop and create and understand this phenomenon. And that's really at the forefront of you have been sitting at. So when we do say 10 years, it seems a really long time, but to have that amount of confidence and alignment with as many groups to be able to have this move forward, I mean, it's a necessity because in the end, how many utilities are there, right? And so how many individual interconnection departments are there? And how many individual planning departments are there? So all of those people have to become educated and taught. And it's not being taught at the university level. I mean, maybe parts of it, but not the tangential causation and the ecosystem of which it all ends up sitting in. So,
and if you just take
amazing work.
One utility, like you said, just take one utility, and within that utility, utilities are incredibly good at doing what they're there to do, right? And so each business unit is really good at doing their roles and responsibilities. But then when you sort of come at it from the angle of this IBR problem is touching every business unit in the company in some way, shape, or form, that's where things get really messy. Is you've got to have this sort of cross-departmental strategic vision of we're gonna kick off something that's going to affect all business units, and it's not this sort of voluntary I'll listen in and chime in. It affects you. So you need to be at the table and have a voice. And we're actually seeing tremendous interest in that in just the last couple of months of entities really recognizing, like, we got to get a handle on this IBR thing. We've got a protection group doing something and a event analysis operations group doing something. And we've got the PMU department and DFR department, and we've got our transmission planners doing all this work. And it's all related, but we got to tie it.
It's very aligned with the grid modernization road mapping mountain that we're all really climbing at different maturity states. And I guess I'll just, for you, we spoke of it, and I think you and I understand the language, but for like any new interconnection, there is a typical group or few people or even one that are overseeing the applications and the information that's being inserted. But if you think about that, information is like a domino effect, because then you have a whole planning organization that may or may not know that the data is being effectively collected or accurate. And then from the planning, ultimately projects are created or projects are negated and then passed into the engineering. And at that point, it's almost too far. So now you have the protection and control engineers and the asset, experts that are all saying, what? and then so you're now creating this interchange of information maybe later in the game. So, and then I guess the timing of it, when we talk about studies, we're not just talking about the minutes and hours phenomena of system stability. We're going all the way into the microsecond time frame of like systems devices at the inverter level that can create issues at that higher level. And so when we talk about studies, like there's many models that need to be built for different phenomena. So I think when we just say models, like there's 4 models that could represent one developed generation project that needs to be studied with very unique tasks. And they all need in the end game to show up to project a real-time event. And so what you spent 10 years doing is taking the real-time events, digging into like what really happened by having real-time data, which is a challenge in itself, right? And then linking that to how the models were ran and trying to create that gap or bridge the gap. And so from that work is where all these standards are kind of rolling out. I mean, that's a high level summary, but I mean, yeah.
So that's very good. Yeah. All these layers of, like you said, the models cover different aspects of reliability, and all of the aspects of reliability are necessary to keep the lights on, right? We can't just sort of start ignoring one, but not the other. And there is a tendency to do that. Well, can't we just solve this with kind of simplifying the way we do all of this? Well, we're sort of creating blind spots, if you will, by doing that,
so
right?
What are the blind spots?
Yeah. So the fundamentals are changing, like kind of where I started of, if we are retiring resources faster than we're adding resources, that's an addition problem, right? Like I'm as a good mentor of mine used to say, we're turning megawatts into wishawatts, right? We're going to hope that they show up and they don't show up, right? Like that's a problem in and of itself. That's the hours time frame, energy assurance, energy adequacy. But then we have the much more kind of fundamental concepts of grid stability, the EMT models, the positive sequence models, all these stuff that the planners, transmission planners are doing, right? And you can kind of go back to the fundamentals of, we have a 60 hertz grid built on synchronous generators, and we're taking all the synchronous generators away. We have a 60 hertz grid now run by a bunch of power electronics, and that's not really intended to be that way, or it sort of wasn't many years ago.
Inertia, smircha? What was that saying?
So inertia is going away. The system getting weaker, if you will. That's a short circuit strength calculation. There's the need for new advanced like grid forming inverter technology that can emulate what a synchronous generator, some of the characteristics that has, right? And just fundamentally, right, to put it at its simplest level, if we keep installing the current resources, which are grid following, and it's a whole separate topic we could spend all day on, we're going to walk ourselves right off a cliff. And every industry expert out there knows that. Right. But we get bogged down on energy adequacy and all these other challenges. And we just, well, that's a technical thing. We'll deal with it later. Well, dealing with that later is going to be a world of pain and extremely expensive to ratepayers. There's this big push, I think, across the board for everyone to be much more proactive than we have in the past to manage some of the characteristics that are changing that we know we have to figure out here soon.
Yeah, those are your blind spots. But any like successes of something that, you could share of something that you saw happening and then ultimately creating, like this can work, the method that we're moving through, and really probably why you really want to get in with the utilities and start supporting and driving, all the things that you learned.
Yeah, I mean, there are a lot of success stories, right? There's a lot of legitimate concerns, and there's a reason for us to be sort of raising the alarms, if you will. And I think it's good to have that discussion, right? But it isn't all negative, right? There's a lot of very positive things going on. It's just it kind of comes down to, are we doing them fast enough? Because the grid's changing so fast, right? So, I think we are seeing really good improvements to the interconnection requirements. Uh, and to be clear there, right? Even the OEMs are asking, give me more requirements. Make them fair, make them reasonable, make them just. Don't make them discriminatory. But the
Right.
more you can tell me how to build my product, the better I can deliver you a good product, right? Don't make me guess at these things. Tell me, right? So we're seeing tremendous work there. IEEE 2800 is now here, right? So industry is going through adopting that, and if entities out there are not yet there, like that's immediate horizon. Like we should all be diving in and adopting 2800. We're seeing better models than we have in the past. We've raised the alarms and said, these are reasons why these models are failing us, so we need to go fix that. So that kind of stems back to the OEMs. The OEMs have got a whole lot better at creating better models for us that capture protections and inner controls and all these things. We're starting to see EMT modeling much more kind of widespread and mainstream, and that's sort
That's a
of
big
where we're
one.
headed. Right. Yeah, it's a tremendous amount of work. Even when I went to school to get my PhD, right, I did a little bit of PSCAD EMT work, but it was an academic exercise, right? So like university institutions need to really ramp up and like train the next generation of engineers to be PSCAD wizards, right? And
And
that's in the
just
works.
just for our acronym detector, well, I just made that up, but EMT is electromagnetic transient. And so that's the models that are being built at the device level, the substation level, where you're really looking at what happens when a certain device switches or turns off unexpectedly. Certain transients occur that could ultimately create a cascading event. So, very important set of studies. And really, as you just said, both of us, developing that EMTP skill was something that was very unique and nichey. And now you're starting to see all utilities embrace that capability and ensuring they have those capabilities in-house and not just an outside support role. So I guess, yeah, I could talk about this all day. Not many people can say that though, right? So what's your main message to utilities, industry stakeholders? How can, and I would just say IEEE 2800 that you just mentioned was a huge topic when we all got together talking about battery energy storage. So it's not just this energy source that we're all talking about. It's really that connection device, which I think gets lost in a lot of the external folks looking at. But anyway, so how can you suggest or leverage, what is happening and the standards that are being implemented to ensure this future reliable grid?
Yeah, I think just kind of culminating on this discussion is, enhancing those requirements, building up the capabilities in house to be able to do some of these advanced modeling, adopting these newer technologies like grid forming, and just being like, generally being proactive about some of the stuff, like looking out further into the future. That the grid at 100% renewables will not work with the current technology, right? And so how many transmission planning departments are running a 2050 case because they've got a 2050 energy like policy directive that says 100% renewable by 2050, right? Like the answer is probably near zero, right? Because it's not mandated. We're always looking 5 years out, 10 years out, maybe 15 years out. When you get to 20, it kind of falls apart. But we got to start thinking about that wildly different grid of the future today if we plan to put a least cost, least regrets, optimal solution in place and not run into potential bad days, right? Outages, right? So the more we can be proactive and the more we can be thoughtful about building those roadmaps and those strategies, that cross-departmental collaboration within utilities and system operators, that's like more critical today than ever, I think. So I think that's my main message.
And I'll just say, I didn't even plan this, but what I continue to hear, especially on this platform with the Grid Mod Pod and really all of the conversations that are happening at AEIC, which is a member a utility member organization where the utilities come together and have this very open, transparent discussion where they feel safe to explore lessons learned. And so we only as beings learn by doing. And so there's been a significant amount of doing without maybe all of the, one would say, as we just been talking about, all of our ducks in a row. But you really don't understand what duck needs to be in a row until you start doing. And so it comes down to how do we as leaders of this transformational time, especially our executive leadership, our external stakeholders, our regulators, our those that are creating the roles of how we can act as a utility, a public utility that's serving all, it comes down to the people and the processes. So that's, and NERC is helping to facilitate the refocusing or the awareness of how some of the processes we've identified, they did work at one time, but now they need to be reconverted. And you're really not growing unless you're, getting uncomfortable and changing. So it's all kind of comes back to the people. How do we have the mindset transformation and how do we act on operational excellence? And so that's like the stake in the ground. I think AEIC brings to the industry the voice. And so I think it's just fascinating that we led right into that conversation that we have to understand and really educate, create, and bring awareness that the resources needed are the people that understand the technical stuff and then allow them the space to really execute within there. So
to create those conduits as well between those experts so they can collaborate. That's tough for an expert, right? An expert's an expert, but they need that project management, that vision, that leadership to connect with their neighboring departments externally and internally, right? And that's where I think the magic really happens.
Right. And another thing is unless you're saying it, you're either ignoring it, you're implying it, or it's non-existent. So really the need to identify the experts in the field and then exactly giving them the space and the awareness that those that need to do the work need someone that puts the dots together so that we can all move forward. So I think that you're right in that space, and I look forward to seeing where you take and how you're helping the utilities. So thanks for taking the time out to share that and share your next journey with us.
Yeah, thank you, Liz. Appreciate the opportunity to be on here.
And for all you listeners, make sure you subscribe so you can continue to be informed of any new episodes that drop. And until then, see you next time.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.